Welcome to Grade 12 Advanced Mathematics. Let's review on how to compute the integral using substitution. It's very simple, but you should practice a lot of questions to master the technique of substitution. Hope you are ready. Welcome to HSM Spot Math. Let's spark our math skills together. Step 1. You are supposed to choose a new variable u in such a way the expressions are of the composition, the innermost expression. Second step, derivate. Once you derivate, your aim should be to replace all the terms in the original integral with the expression involving your new u and du. Once you replace, evaluate the resulting integral. In case if you can't evaluate the resulting integral, you should analyze your u again, whether you have selected the correct u. Once you find the antiderivative of the u, again switch back to your x with the assumption you have taken. Let's dive into solving problems. Please comment below what are the problems you are facing when you solve using substitution. If you get the right answer, don't forget to like the video. It will be a great motivation for your friends. Pause the video, try it out, and let's see here how to work it out. First of all, when you look at this, look at the power. You have root x. So let's take our u as root x. Once you fix our u as root x, what will be your du? It is nothing but 1 by 2 root x. Don't forget to add dx over here. You can do it in different way. You can identify only dx, then you can substitute in the place of dx, or you can combine dx by root x. You can see here dx by root x. Extra 2, you can swap it to the other side. You can follow any method. At the end, let's find what is dx, which is 2 root x du. So when you simplify, you can cancel the root x. So you are left with the 2 e power u du. 2 is a constant, you can take it outside. And what about integral e power u du? Exactly, e power u plus c. Now you can replace your u with the assumption that is your root x. Either you can do it like this, or as I mentioned in the beginning, you can have dx by root x, and in the place of dx by root x, you can substitute 2 du. Then again you will get the same step. So let's move with the third question. In this particular question, if you look at it, what about 1 by x? Let's take our u. So once your u is 1 over x, what about du? Minus 1 over x square dx. So your derivative formula should be thorough. Your integration formula should be thorough. Only then you will be able to solve these questions. Okay? Fine. Let's proceed. Here again, if you prefer, you can have dx by x square as negative du, and you can substitute it instead of dx by x square. Or you can find dx value and then you can replace it dx. And you can cancel the common term x square. So you are left with negative integral cos u du. And what is integral cos u du? Exactly, it is sine u. Already you have a negative sign, so it becomes negative sine u plus c. And what is your u? Very good, it is negative sine 1 over x plus c. Now let's proceed with this question. Look here, under the square root you can see a ln x. So let us take our u as ln x. So what is du? 1 over x dx. Here again, instead of dx by x, you can directly substitute du. So you get integral root u du. So once you get integral root u du, you can integrate it u power half. How will you integrate? Using power rule, add 1 on the power and repeat the same thing in the denominator, which is 3 over 2. Now don't forget to flip your 3 over 2, which becomes 2 over 3, and your u power 3 by 2 can be rewritten. Since your denominator is 2, it becomes square root of u power 3. Now what is u? Exactly. So it becomes 2 over 3 root ln x power 3 plus c. So be careful when you replace this u is having a power 3. So ln x within the bracket then power 3. Otherwise it looks ln x power 3, which is completely wrong. So you have to be very careful. Let's try solving this question. When you look at here, you have tan x and then ln cos x. So let's assume ln cos x as our u. So once you have ln cos x as our u, what about du? Ln means it is 1 over. So 1 over the function cos x, and don't forget to derive cos x as chain rule, which will be negative sin x. Then automatically you will have a dx there. So it becomes negative sin x over cos x dx. And you all remember the formula of trigonometric ratio? So what is sin x by cos x? Wow, that's great. It is tan x. So it is negative tan x dx. So in the place of tan x dx, you can substitute negative du, or you can have dx as tan du over negative tan x. Then you can cancel the tan x. Both will result in the same answer. So whichever you find it comfortable, you can follow that method. Okay. So once you get negative integral u du, you can use the power rule, which will be u square over 2 plus c. And what is u? Ln cos x. Please use the bracket properly. Even if it is multiple choice, there will be confusion of brackets. So please be alert before you lock the answer. Let's try out this question. If you look at, you have root in the denominator and moreover 1 minus x power 4. 1 minus x power 4 can be written as x square the whole square, so that we can relate it with our known integration formula. Now let's assume u is equal to x square. So what about du? 2x dx. So for dx, you can have an idea du by 2x. Let's substitute and cancel the common term, which is x. Now you are left with 1 over 2 as a constant. Don't forget to take it out. And inside you have du by root of 1 minus u square. What is the integration? Exactly, sine inverse u plus c. And now what is u? X square. So that's the end of this particular question. Hope you followed. Same idea you will proceed it in the next question as well, where you will assume your u as complete 1 minus x power 4. Why we have taken? Because we are going to connect it with our numerator x cube dx. So your x cube dx is du over negative 4. Now when you substitute, you get your simplification as negative 1 by 4 integral du by root u. And root u in the denominator can be written as u power negative half. Now when you integrate, you will get it u power half. How? When you add 1. Negative half plus 1 is nothing but half. Now you can cancel or you can flip it, and then also you can simplify. It's up to you. You will be getting it as negative half u power 1 by 2, which is nothing but root u plus c. And what is u? 1 minus x power 4. Now let's try this question. Look at your denominator. You have x power 6. And in the numerator you have x square. So you should understand the denominator has to be of something like square. How can you make x power 6 as square? Exactly, x cube the whole power 2 is nothing but x power 6. So let us consider our u as x cube. So your du is 3x square dx. Here itself, if you prefer, you can see your x squared dx, which is du over 3. This 3 will go to the other side. And you can replace it in the place of x squared dx. Or, as I explained here, you can have the dx value, substitute for dx and then cancel the common term. Any method you can follow. Now, what is the integration? Tan inverse u plus c. And what is u? X power 3. Let's move to the next question. If you look at here, your denominator x power 6, when you derive, you are getting your numerator x power 5. So let's understand our u is 1 plus x power 6. And when you derive it, you will get 6x power 5 dx. So here is the rule. The derivative of the denominator is nothing but the numerator. But what is missing? 6 is missing. So we balanced by having 1 over 6. Or you can have an understanding. Take only x power 5 dx as in your question. And what is x power 5 dx? Du by 6. You can substitute directly du by 6. And the denominator 1 plus x power 6 can be written as u. So it is nothing but 1 by 6 integral du by u. You can even arrive like this. The same thing you will get it if you follow this method also. So the method matters. Whichever method you are doing, please do it correctly. So now what is integral du by u? Exactly, len u. And what is absolute value? Don't forget, okay? So what is u here? 1 plus x power 6. So your final answer is 1 by 6 len absolute value of 1 plus x power 6 plus c. Here it should be of absolute value. Because it matters when you handle a negative direction, it will become positive as it is inside the absolute value. Sometimes if it's of the even number, it can be of having no effect, because even number, even if you have negative or positive, it's going to be the even power. It's going to be the positive. But whatever it is, it's better to use the absolute value to avoid confusion. Let's try this question. Please pause the video and try it out. If you get the right answer, please comment below. If not, please mention the question number, which question you struggled a lot. Let's see part E. If you see your denominator, it is 1 plus x square. Somehow you are getting connected with tan inverse formula, right? But you can look at here, your numerator is also a combination of two terms. So let's rewrite the integral by splitting it into two halves. The first term with 1, that is 1 over 1 plus x square, and the second term with x, that is x over 1 plus x square dx. Now if you look at here, the first half, no problem, directly you can apply the formula, which is tan inverse x. But the second part, if you look at the term, it is the derivative is 2x dx. You are missing a 2 in the numerator. So when you include a 2 in the numerator, don't forget to divide by a number 2, same number. Now you can use the formula len denominator, because the denominator derivative is nothing but the same as the numerator. And don't forget your extra half here. So let's continue. We get tan inverse x plus half len 1 plus x square plus c. When you move to your second question, it's also absolute value. Since it's of the power is even, we just proceeded with a bracket, but absolute value will give you a clear idea. Now, when you concentrate on the second question, 1 minus x square in the denominator, we don't have any direct formula, so we'll think about it. How can we simplify? We learned a square minus b square identity, so we use that, which is a plus b times a minus b. Let's cancel the numerator with the denominator 1 plus x. So you are left with 1 over 1 minus x dx. Now let's have an identity like 1 minus x. When you derive it, you will get negative dx, but you're missing with one negative sign here, right? So let us include a negative sign. At the same time, don't forget to include a negative sign outside as well. So you get negative len 1 minus x plus c. Now let's proceed with the next question. This is a Slightly a tricky question. Please be careful. When you look for your denominator t plus 7, when you derive you get dt, but you have an extra 2t plus 3 here, right? So let's proceed with our u, that is t plus 7. Du is dt. So in the place of dt, you will substitute du, and in the place of t plus 7, you will substitute u. And what about your 2t plus 3? Find t from here. T is nothing but u minus 7. Substitute in the place of t. So you get integral 2 times. For t, you will be replacing it with u minus 7 and t plus 7 with u and dt with du. So you get such an expression. When you open the bracket, you will get it like this, and simplified version, you will get it like this. Now let's split the integral. 2u over u minus 11 over u du. So you get integral 2 minus 11 over u du. So 2 du is nothing but 2u minus 11 du over u integration will be len absolute value of u plus c. And what is u? T plus 7. Here again, be careful. We will consider our u as t plus 3. When you consider our u as t plus 3, what is dt? Du. Let's substitute for dt du. Let's substitute for t plus 3 as u. But what about this t? U minus 3. Let's bring all the substitution here. So a minus b the whole square, which is a square minus 2ab plus b square format. Now let's individually simplify, open the bracket, because cube root of u is u power 1 by 3. When it goes to the numerator, it becomes u power negative 1 by 3. When you open the bracket, you have to add the powers. 2 plus negative 1 by 3 is 5 by 3. Then 1 plus negative 1 by 3 is 2 by 3. And 9 u power negative 1 by 3, because 9 is a constant. So you'll multiply just like that. Now let's use the power rule. And don't forget to flip the denominator. 8 by 3 will become 3 by 8. 5 by 3 will become 3 over 5. 2 by 3 will become 3 over 2. And later you can simplify. All are having the denominator 3. So all the functions are of cube root. First one is u power 8. Second one is u power 5. And the third one is u power 2. Now replace your u with your t plus 3. So that's the end of this particular question. And let's delve into the final question of this particular review session. Here, let's assume our u as 1 plus root x. When you derive it, you will get 1 by 2 root x dx. So, what is dx? 2 root x du. From the first expression, we will get what is root x. It is nothing but u minus 1. Let's substitute all the expression and let's open the bracket. Now let's simplify. You will get 2 minus 2 over u du. Let's integrate. You get 2u minus 2 len absolute value of u plus c. Let's substitute for u, which is nothing but 1 plus root x. Here, if you want, you can avoid the absolute value, as root x is always greater than or equal to 0. But still, absolute value, it's better to use. So that's all. That's all for today. See you soon. Until then, keep revising, keep practicing. Wish you all the best. Bye-bye.